For 7.3, we're looking at LCD. This is the least common denominator. And this is probably what people, or where people get confused the most with fractions. I've seen where people have tried multiplying and dividing after finding the least common denominator. So you find the least common denominator when you are either adding or subtracting. In the algebra world, this is called combining, is when you're adding or subtracting. In your video session, you're going to have a 7.3, what I call a preview, which is really a review. And I'm referring you to a couple of videos that are not mine. So be sure and watch those and then try the practice homework for that before you attempt this section. So what we're going to have to do is we need to find the factors. Then we're going to find the LCD. And then we have to make equal fractions. So I'm going to use something, just regular old fractions, to do this before we get into using our rational expressions, which are quite a bit confusing. So let's go ahead and let me find, I don't want to go that far. Let's do it here, and let me find a problem for us to work on. So we have three fractions here, and for what we're doing now, it doesn't matter for adding or subtracting them. I want us to see how to find the LCD. And we're focusing on the denominators. So let's look at 14. And we want to write the prime factors. So 14 is 2 times 7. 84, we could do a tree. And so let's go ahead and do that. So if I come over here and do a factor tree, I know that 4 goes into this number, 21. 4 times 21 gives me the 84 that I started with. But neither of these are prime. And we're wanting to write the prime factors. So let me put this. We want prime factors. So 4 becomes 2 times 2. 21 is 3 times 7. And so 84 is 2 times 2 times 3 times 7. Then our other denominator is 9, and we know that it is 3 times 3. Those are the prime factors. So what we're looking at here is we're looking for the largest or equal grouping of each type of number. And so what I mean by that is, here I have a 2. Here I also have some 2's. And if and they all have to be included. So I have to include every type of number. So when I look at the 2's, the largest grouping is here. Those. When I look at 7, I have 1 here and 1 here, and so that's when I'm talking about the equal. It doesn't matter which 7 we pull. I'm going to pull that one. When I look at 3's, I have 1 and I have 2, so I have to pull both of those 2's. So what happens is then my LCD is the 2 times 2 times 3 times 3 times 7. And when I multiply all of that out, I get 252. So what this means is all of these numbers 14, 84, and 9 will go in to 252. And this number is going to be a little bit smaller than if I just took and multiplied all of these denominators. I can. That's one way to find a common denominator, is just multiply the denominators that you have, but it won't be your L. It won't be your least. And so this is the method that we're looking at. Okay, so that should be a quick review, but this is from that little, the videos that I've listed in Learning Module 6. And so you want to go back and do those if you haven't done it yet. Okay, so let's go ahead and finish this. Let's make the equal fractions. So if I have 3/14, and now I know that my denominator is going to be 252, then I have to change the 3 also. Now there's a couple of ways you can do this. You could break out your calculator and do 252 divided by 14 to get the number that we multiplied here to get this number, or you could look at 14 and our LCD. So if I look at that, then I've got a 2 and a 7 here. And so what's missing is this 2 times 3 times 3, which would give us 18. Which if I do the math here, I should get 18. So let's take just a second and make sure that's what we're going to get. So I broke out my calculator and I did the division and I did get 18. So what that means is I'm going to multiply this by 18, the top and the bottom. So this gives me 252, and then 3 times 18 will give me 54. So now these two fractions are equal. They are equivalent. Now let's take 25 over 84 and do the same thing. So we have 25 over 84. When I look at 84, I've got 2 2's, and so there's those 2 2's, a 3, and a 7. So what's missing there is a 3. So again, you could have gone, 252 divided by 84 and gotten the 3. Or you could look at your LCD and see what's already here for 84 and find what's missing. So I'm going to multiply the 3 times the 25 to get 75. Then our last one is 1 over 9. And again, we want to get 252 for our denominator. So how do we go from 9 to 252? Well, let's do some division and figure out how many times does 9 go into 252. So do the division, or do what I suggested earlier. This is what I'm using for my LCD. And here is what 9 is. So 9 can strike that and strike that, and what I'm left with is 2 times 2, which is 4, times 7, which is this 28. So 9 times 28 gives me 252, and 1 times 28 gives me the 28. Okay, so that takes care of a very quick review of how to find the least common denominator and how to create those equivalent or equal fractions. So let's move into the more difficult part, which is doing this with our expressions. Okay, so get these two fractions written down. And then what we want to do is we're looking at factoring. So 3x plus 9 becomes 3 times x plus 3. Those are the factors. Then we want to take this other expression in the denominator and factor it. Well, it has a 3 in this first position, and here it is the GCF. I can take it out of 18 and 27. So we want to do that first. And then we want to finish this. And so we've got 3, and we'll factor this trinomial. Everything's positive, so that looks good. Okay. So let's focus on what we're looking at here. This is what we're looking at, and this is the prime factors for this expression. So remember what I said. All of this has to be represented in its largest form. So when I look at 3, I have 1 of each. Okay? So that means my LCD will have a 3. I have x plus 3, but I have it here twice. So we'll pick up these. So x plus 3, x plus 3. Okay? All right. So now we need to change these. This is my LCD. I need that to be here for both of these. Okay. Now notice that what we have here, what we factored here is our LCD. So if the bottoms don't change, neither does the top. Here, we've got this 3 times x plus 3. So we already have this inside. We've already got that. But we need this to go to all of this. So what's missing is this x plus 3. So that's what we have to multiply times both. Well, it's already been multiplied here. And so now I need to multiply it here. X plus 3. So we'll have 14x plus, and then 14 times 3. So we've come up with our LCD, and we've created our equal fractions. If we were to add or subtract these, then we could go ahead and do that and combine the 8 and the 42. But what we're doing for right now is just coming up with the LCD and creating our equal fractions. I know this can be very confusing. Most people hate fractions already, and then when you start putting letters inside the fractions, they just don't like it. I don't blame anybody for that. Let's go ahead and look at some other examples. We'll have, they're going to give us the problem, and they're going to give us the denominator they want us to use. So what we have to do is figure out what's missing from here that we have here. And to do that, we really need to factor this. So let's go ahead and factor that 6x plus 4. Okay? So that's, we've factored that here. And you see we've got the 6 and the x plus 4. So what's missing here is the y. And that's what we're going to multiply times the 5. So to make this an equal fraction, it'd be 5 times y. Okay, so this is what we are given. Everything here is what we are given. So what we need to do is we need to go ahead and factor both of these denominators to see what we have in this one that we don't have here. So take out the GCF. Let's take out a 20 here. Okay. Now notice I have the x squared minus 3 in both places. Here I have a 5 and it goes to a 20. So how do I go from a 5 to a 20? I multiply by 4. So that means that's what I'm going to do up here, is I'm going to need to multiply by 4. So 4 times 7, and we're going to have 28y minus 28. These are equal fractions. This fraction is the same as this one. It represents the same amount. We just use different numbers. Okay? Again, what I did is I factored the denominators, and then I saw, okay, I already have that. How do I go from a 5 to a 20? That's when we came up with the times 4, and that's what I used here. Okay? All right, let's see if we're ready to practice yet. Let's go ahead and do a problem that already has an LCD. Alright, so notice that the denominator is already the same. So we're ready to go ahead and subtract. But what you have to remember is this negative goes with this 2x and with this 4. So 3x minus 2x is going to give me 1x, and I'm going to put the 1 just to emphasize it. We won't leave it. And then 9 minus 4 is going to give us a 5. And it's all over this x squared plus 3x minus 10. But you know, it's a fraction. So I always have to reduce a fraction. So let's go ahead and simplify this a little bit. Factor the bottom, because that's the only way we'll be able to reduce this. We've got a minus here, so that means I'm going to have a plus and a minus. I've got a positive here, so my large number is going to go with my plus. And, you know, this numerator is going to, we're hoping to cancel something. So it should help you in your factoring. Go ahead and get to this. We've got x plus 5 over x plus 5. This all cancels out, and we always say it cancels, but it really becomes 1. And so that's what we're left with here, is that 1. And so our answer is going to be 1 over x minus 2. Okay, so that's going to take care of 7.3. In 7.4, we will be putting all of this together, where we will come up with the common denominator, we will make our equivalent fractions, we will subtract or add, and then we'll do the reducing also. So hopefully you want to understand this very well before you move to the next section, or it will be disheartening. I'm trying to think of a good word. It will be stressful. There we go. If you don't understand the 7.3, then 7.4 will be stressful. Good luck.